11.2 talks about separation of variables or separable equations. So a separable equation or separation of variables would be a function or a relation in which you could separate the function in terms of x with dx and the function in terms of y with dy, meaning identical to what we learned in our calculus course, or pretty much what we learned prior sections. So solve differential equations. Those are separable equations. What we do, and if I cross multiply and divide by y to the fourth both sides, and if I integrate, this is really y to the negative fourth, so add 1 to the power, divide by that, and this would be negative sine of x plus c. So if I multiply by negative 3, and this is 1 over y cubed equal 3 the sine of x plus c. So the reciprocal of this side equal the reciprocal of this side. And to solve for y, you take the cube root of both sides. And that would be the solution to this differential equations. Meaning, if you take a derivative of that, plus take that y and raise it to the fourth power, multiply it by cosine of x, you'll get a 0. Second problem deals with another separable equation. So this is x dy equals 1 minus y squared under a square root dx. If I divide by x both sides and the square root of 1 minus y squared, I'll get dy over the square root of 1 minus y squared equal dx over x. And again, that's what separable mean. If I integrate, this is the inverse sine of y, and this is natural log of absolute value of x plus c. So y would equal the sine of natural log of absolute value of x plus c. And that would be my answer. Next problem, I already have y and dy on one side. All what I have to do is separate that on the other side and integrate. And that would be y plus y cubed over 3. And that's e to the x plus c. Here I can't solve for y. Well, that's pretty much it. And if I look at part D, this is dy dt equal 1 plus t squared over y. So if I cross multiply, y dy equals 1 plus t squared dt. And if I integrate, I'll get y squared over 2 equaling t plus t cubed over 3 plus c. So y squared will be twice t plus twice t cubed over 3 plus c. You could write 2c if you want. It's the same thing. It doesn't matter. And if I want y, and here we gotta be careful in this section. Actually, let me add a bit more space. If we want to solve for y here, we square root both sides, and you gotta be careful. Every time you square root both sides, you pick a plus or minus. and that would be my answer. And if you look at the next problem, same deal. I could write this as e to the x times e to the y dy equal dx. Divide both sides by e to the x. Or e to the y dy equal e to the negative x dx. Integrate. And that would mean e to the y equals negative e to the negative x plus c, and y would equal natural log of c minus e to the minus x. And that would be my final answer. Now, if they gave me the initial conditions, and they give me the initial conditions few ways, either they write it this way, or they say y of 1 equal negative 2. So, this is dy dx equal 1 minus x over y. If I cross multiply, and I need one more line, if I integrate, I'll get y squared equaling x minus x squared over 2 plus c. And that is y squared over 2. Now, I'm going to take this and I'm going to work it out two different ways. First, I have the initial condition, so I'm going to say before I go on, y squared equal 2x minus x squared plus c, or you could say y squared equal 2x minus x squared plus 2c. So I'm going to show you that it doesn't matter which one you pick. Whether you pick c or 2c, you're going to get the same answer. Here, you're going to take the square root of both sides. And you're going to get y to equal plus or minus the square root of 2x minus x squared plus c. Y equal a negative 2 when x equal a 1. If I put a 1 in there, I will get 2 minus 1, which is 1 plus c. Now for this to work, automatically, I must eliminate the positive. This way, when I divide by a negative, I have 2 equal the square root of 1 plus c, 4 equal 1 plus c, that means c equal a 3. So, I could come in here and say y equal negative the square root of 2x minus x squared plus 3. And I'm done. If you were to choose 2c, again, you could do that. You would say, let's square root both sides, and you will get y to equal plus or minus the square root of 2x minus x squared plus 2c. Well, y equal a negative 2. When x equal a 1, if you put a 1 there, that's 2 minus 1, which is 1 plus c. Which means, again, you have to eliminate the positive regardless. And now you could say 2 equal the square root of 2c. So again, some students are confused. Why am I not multiplying the c by a number? Because it's a constant. You multiply by a number, it's still a constant. Square both sides. And 3 equal 2c. So here I'm getting c to equal 3 halves. And here my answer would be y equal negative the square root of 2x minus x squared. Now, if I put 3 halves in there, 2 times 3 halves, isn't that a 3? And do you see that whether I used c or 2c, I got exactly the same answer. So, when I multiply or divide C by a number, I always write C. If you want to keep track of that 2C, then you're doing the same thing. You could do that if you want. Just easier to just write a C because it makes no difference. And the same deal with part B. If I really, let me think. If I multiply both sides by t, and if I divide by y squared, there it is, and if I integrate, I'm looking at the integral of y to the negative 2 dy equal natural log of t plus c. I'm looking at add 1 to the power, divide by that. So, negative 1 over y equals natural log of t plus c. Let me find c. This says y equal a 3 when x equal a 1. But I know that natural log of 1 is a 0. So I'm getting c to be negative 1/3. So right there, I'll take that and say, when I have negative 1 over y equal natural log of t minus 1/3, if I multiply by a negative, and the reciprocal will be the reciprocal of that, and that would be my final answer. Now you could simplify if you really want. It's up to you, you don't have to. And say that's 3 over negative 3 natural log of t plus 1. Those two are saying the same thing. And I have one more example to go, and here they're already separated. I have the function of y with y, the function of t with t. All what I have to do is move that to the right side. And if I integrate, I'll get the sine of 2y, integral, so you divide by 2, equal the cosine of 2t divided by 2 plus c. Again, I have initial conditions. It says if t equal pi over 6, then y equal pi over 2. So if I substitute that in, this says the sine of pi divided by 2, but I know the sine of pi is 0. Here I'm looking at the cosine. 2 times pi over 6 is pi over 3. And cosine of pi over 3 I know is 1/2. So 0 equal 1/4 plus c. So c is negative 1/4, which means my equation, I'm talking about this equation, says the sine of 2y over 2 equals the cosine of 2t over 2 plus, or minus 1/4 I should say, multiply by 2, and 2y will be the inverse sine of cosine of 2t minus 1/2, and y will be divided by 2, and there it is. That's pretty much it for this section.